Hi, good morning. In last class, we discussed about ring main system protection, and today I am going to discuss about current graded protection, like that. Yesterday we seen like zone of protection, and same like current graded protection. According to if fault is in between the A and B, that current is 12.5 ampere operating current. Okay, and if fault is B and C, in between the B and C, that operating current is 10 ampere, and if fault is after the C means that is 5 ampere. According to the operating current is decided based on the fault. Okay, if fault is here means then it is that fault is should be more than 12.5 or more than that, then that relay will operate. Okay, and this is the relay pickup secondary current. Okay, here only that sensing point is there. If fault is here, y means some of the current here 5000 amperes and 4000 amperes, 3000 amperes, because some of the loads are connected here, that may action. Okay, if first it will see the current at this location. Okay, and if it is at more than 10 ampere means then that relay will operate. Okay, this is current graded protection, and you can see here from here we are sensing the, by using CT we are sensing the current flowing through this line. Here also CT, here also CT. That CT output we are giving to the near and this relay as well as this relay as well as this relay as well as the main relay. Okay, all are there, like that we are connecting. And next we can see what are the difficulties we are facing with current graded. That relay is not discriminate between the fault in the next section and the end of first section. Okay, if fault in the next section or end of first section, that discrimination is not there. Okay, both are taking as a same. Okay, that is the one of the disadvantages we are facing with current graded protection. Okay, hence a discrimination, the relays is set to protect only part of the line, usually 80%. Like you can see here we are protecting up to, this is 100% means from here to here we are protecting up to here 80%. Okay, that's why it will if fault is in this bus means then it discriminates. Okay, whether fault is other side or nearer to the first section, that is. And one more, for the ring mains parallel faders, whether current is flowing one direction or another direction, system is without directional control is not suited. Okay, that is the one of the disadvantage of this current graded protection. And if it is a parallel connection or parallel faders or ring main, and current can flow either direction, but it is not without directional control is not suited in this protection. Next you can see this is the universal torque equation. You already know this is universal torque equation. Torque is first k1 I square means torque is that proportional to the I square, and v square va cos theta minus tau. Okay, and k4 is the some constant. This is universal torque equation, you already know about this. And after that how that impedance relay is operating means that Z seen by the relay E should be less than the Z set. Z set is the previous set value. If it is less than that one means then this relay will give the trip signal, otherwise relay will not operate. That is how these this jet set and that impedance relay characteristics are there means now you can see. And how distance protection is happening means this is the generator and transformer and bus bar, and this is circuit breaker, CT, relay, and PT, and one line, and again bus bar, again another line. If fault is in the in between the A and B, bus bar A, bus bar B, then it is taking this relay is taking as a internal fault. Okay, if fault is at after the B means it is taking as a external fault. If fault is at the B point means that is reach point fault. This Z set by the this relay is reach of this from here to the here impedance. Okay, if impedance is less than that one means then if fault is happened means that impedance is from here to the here only, that is less than the this total impedance, then that relay will operate. If it is here means then that relay will is in threshold. Okay, if it is here means that relay will not operate, wait for some time, then one more we are giving one more protection. And if the here also one relay and one circuit breaker is there, it has to operate, and this system has to protect. Okay, active condition, because fault is here, this system has to should be in active condition. That's why this relay has to operate. If this relay is not operating means then this relay will operate. Okay, and next you can see impedance relay diagram. It is looking like this, and this is the RX diagram. It is a that dotted line represents the jet, locus of jet. This is okay, and how we are using this one means we can see here. This is the main diagram, characteristics of impedance relay. If point that relay seen by the impedance seen by the relay is under this region, means then relay will operate, otherwise relay will not operate. This circle is the set. Okay, that circle is the whatever we are giving that set value, that is in first and that this is the set value from here to the here impedance, that is set value. That circle this is the set value of the relay. Okay, if inside the circle means then relay will operate, outside the circle means relay will not operate. Next you can see fault characteristics of relay, and if it is a fault is F1 means then relay will operate, F3 means relay will not operate, and F2 means relay is in threshold condition. Okay, and how this relay is we are constructing is then we can see this is the trip coil, trip circuit. Okay, trip output, and from here we are giving this to the voltage coil. Okay, here also one knob is there that will attract. If voltage is more means then this will attract this one. Okay, then trip circuit is in open circuit, and if this is current coil, this is voltage coil. Okay, we are calling as a voltage coil as a restraining coil. If fault is there means what happened, if fault is there, current will increase and voltage will decrease. because so that impedance is very less, then voltage current is more, voltage will decrease when compared to. Then current is more means what happened, this will attract this one, because here we are connecting spring, and this will attract this one means, then this will come down and this will go up, then this is will touch the these 2 points, this black color knob will touch the these 2 points. Then what happened, that both are short circuited, and that trip signal will go to the circuit breaker. Okay, if voltage is more, current is less in normal condition, then this will attract this one. Okay, and these are in open circuit. Then restraining, this is the operating, okay, of the impedance relay. Next class we can see.